Warwick Crop Centre recently hosted a RAP-funded trial to investigate the use of digestates in protected strawberry production. Digestates are the product of anaerobic digestion, which is becoming a valuable way of converting organic wastes into something useful. A glasshouse trial was established using 6 treatments and a commercial control. We actually did very little to the digestates before the experiment. They had to be diluted to between 20 and 50 times their original strength, and we added a little calcium and a little nitrate, but other than that we used them as they were delivered.
We looked at 6 different digestates sourced from around the country and produced from various different feedstocks such as food waste, slurry and maize. The first thing we did was to analyse the digestates to look at the availability of the different nutrients. It was immediately apparent that there was far too much nitrogen in all of the digestates, so that we had to dilute them. Also, 100% of the ammonium, 100% of the nitrogen was in the form of ammonium, which would potentially be toxic to the plants and also would produce a very acid root zone, which would affect the availability of the other nutrients. So we addressed this by adding in a bit of nitrogen, a bit of nitrate nitrogen, in the form of potassium nitrate, which would be similar to what a commercial grower would do, in that they'd supply the plants with extra potassium and nitrogen during the fruiting and flowering stages. We also needed to give the plants a little bit extra phosphorus and some extra of some of the micronutrients. We also needed to include a coarse filter to help prevent the digestates from blocking the irrigation system. So what did we find? Well, 3 of the digestates did as well as the commercial feed in terms of both yield and quality of the fruits. The other 3 had a little bit of a struggle in taking up enough calcium, not because there was any less calcium in these feeds, but because the way the pH of the root zone responded to these digestates was slightly different from the other 3, and it affected the availability of the calcium to the plants. We also did regular taste testing, and we found that in general, as far as flavour was concerned, there was a preference for the digestates above the commercial feed, which is interesting. We did have some issues with blockages from 2 of the digestates in the later stages of the study, but the other 4 digestates were completely fine.
Overall, the trial was a success. Whilst yields were not quite up to commercial standard, the quality of the fruit and the taste of the fruit was very good. We did taste tests on both students and visitors who confirmed that there were no issues. There are a number of downsides, however, to using digestates for production of strawberries. First of all up is the logistics of actually storing and using large volumes of liquids. Growers are not just set up to do with it. Secondly, there are odour problems. I mean, digestates smell. You just have to live with that. But that's not as bad as you might think. Thirdly, perhaps more seriously, there are potential issues over pathogens. And whilst the digestion process should itself eliminate any pathogens, growers are still a little bit reserved when it comes to their use. And fourthly, one that's not actually applicable to the growing system is that consumers are still very wary of using food and fruits that are grown using waste products. And this is an area that will have to be investigated or resolved before we can start to use digestates as fertilisers. So in summary, yes, we can grow strawberries using digestates. There is some financial saving compared to synthetic fertilisers, but I would suggest that at the moment the savings are not great enough for a change to occur.